Good afternoon. Now, yesterday I have discussed you the definition of set and types of sets like empty set, singleton set, finite set, infinite set, subset, equal sets and equivalent set. Now, today I am going to discuss that sets with example, and I will also tell you how these definitions, these facts are asked in different competitive exam. Question number 1, I will discuss all the definition with example with questions. How I will tackle the question. Find the pair of equal sets. Question number 1. Your question is find the pair of equal sets. If any, give reasons. A, B, all x such that x is greater than 50 and x is less than 5. C, all x such that x minus 5 equals to 0. D, all x such that x square is equal to 25. E, defined as all x such that x is an integral positive root of the equation x square minus 2x minus x square minus 2x minus 15 equals to 0. In this question, you have to find the pair of equal sets. You have to identify which sets are equal. So, in order to find out this thing, you have to write each and every set in roster form. Here, one set is given in roster form, other is given in set builder form. Without writing it in roster form, you cannot decide that which set is equal to whom. So, your set is already given in roster form, that is singleton set 0. And while writing the set B in roster form, you see that B consists of all elements x for which x is greater than 15 and x is less than 5 simultaneously. This is not possible. So it has no element. B is a null set, B is an empty set, A is not because it has one element 0. Now see, in the set C, your element x satisfies the linear equation x minus 5 equals to 0. So your value of x is 5. It has only one set element. It is a singleton set. Now D consists of two elements minus 5 and 5 because their scores are 25. And E, you solve the quadratic equation x square minus 2x minus 15 equals to 0. X square minus 5x plus 3x minus 15 equals to 0. X in the bracket x minus 5 plus 3 in the bracket x minus 5 equals to 0. X plus 3, x minus 5 equals to 0. The value of x is minus 3 and 5. Here your roots x of the given quadratic equation is minus 3 and 5. Minus 3 is the negative root and 5 is the positive root. So in set E you have given that it is an integral positive roots of the equation. X square minus 2x minus 15 equals 0. So E is also a singlet in set 5. Now you identify. Can you say A equal to B? No. Can you say A equals to C? Because why? Why A and B are not equal? Because their elements are not same. They are not identical. A is not equal to C because their elements are not identical. Element of C and D are not identical. Therefore, C and D are not equal. And A and E are not equal. In this way, you can say that A is not equal to B, A is not equal to E, A is not equal to C, A is not equal to D. A is not equal to any one of the remaining set. And now, what about B? B and C are not equal. Already that is mentioned. So now we find out whose elements are identical. You find out the set out of that 5 sets whose elements are identical, C and E. So in this way, you can say the sets C and E are the only 2 sets that are equal. This is one question on equal sets. Now I am taking another question. Question number 2. Are the following sets equal? Give reasons. Give reason. Number 1, A 2 3. Second, B is defined as all x such that x is a solution of x square plus 5x plus 6 equals to 0. Third, this is the first question. And now second, your second question is A is defined as all x such that x is a letter of the word FOLLOW. B is defined as all y such that y is a letter of the word wolf, WOLF. Now you have to give the reason in support of your answer whether the set A and set B in first case are equal or not. So as I told you, you write the given set in roster form. Your first set A is already in roster form, that is 2 3, and for set B you find the solution of the quadratic equation x square plus 5x plus 6 equals to 0. Then you follow the factorization by splitting middle term. You can write its factor x plus 3, x plus 2, that is equals to 0. In this way, your value of x is minus 3 and minus 2. So solution of this quadratic equation is minus 3 minus 2, and set B is defined as minus 3 minus 2. Now after writing this in roster form, you observe that the elements of set A and B are not identical, they are not same, so therefore the set A and B are A is not equal to B because that is the reason, you have to write the reason, because elements of set A and set B are not identical. Are not identical. Now when you take second example, in the same way you have to rewrite the given set in roster form. Your set A is a letter of the word follow. F L O W. And set B is the letter of the word wolf. F L O W. Now in this case the elements of A and B are identical, they are same. So therefore by observing A and B you can write A equal to B because elements of set A and set B are same. That is identity. That's why they are equal. Now I am writing one question that is asked in competitive examination, and you must know that how the question on the definition of empty set, singleton set, etc. the question are framed in IIT examination, NDA and other competitive examinations. Question 3. Which of the following set is an empty set? Which of the following set is an empty set? A is equal to x such that x belongs to n, 2x plus 5 is equal to 6. B, set B equals to all x such that x belongs to n, 1 is less than or equal to x is less than or equal to 2. C, set E equals to all x such that x is an even prime. D, set G is defined as all x such that x belongs to Q, 1 is less than x is less than 2. Now you see, you have to identify in this question among all 4 answers A, B, C, D, you have to identify which set is an empty set. You can find only when you write all the set in roster form. So in first case, set A consists of all natural numbers which satisfy this linear equation. When you solve the given linear equation and you find the value of x, can you have the value of x as a natural number? Because the set A consists of natural value of x. You solve this linear equation and find the value of x. 2x is equals to 6 minus 5, 2x is 1, x is equal to 1 by 2. 1 by 2 does not belong to n. So your set A is empty set. It has no element. Your set A has no element. It is empty set. Might be other sets also satisfy the definition of empty set. Come to set B. This is defined as all x such that x belongs to n. X is a natural number and it is taken from 1 to 2 including 1 and 2. So set B consists of 1 and 2. Set B has 2 elements. It is not empty. Now come to third part. Set E defined as all x such that x is an even prime. When you start making observation about the set of prime numbers, your first prime number is 2. 2 is an even prime. The set E has one element, that is 2. It is a singleton set. Now you know that between any two integers, between any two rational numbers, between any two real numbers, there are infinite number of rational numbers. So your set G is the example of infinite set. This is infinite set. So now tell me, which is the answer? Definitely you can say your A is the answer. So this is an empty set. So you must know how these definitions are used to frame the question for competitive exam. Now I am taking next question. Which of the following set is not a null set? Which of the following set is not a null set? A set of odd natural number divisible by 2. B set of even prime numbers. C, this is defined as all x such that x is a natural number x is less than 5 and x is greater than 7. D, this is defined as all x such that x is a point common to parallel lines, common to any two parallel lines. Now you must see. In this question you have to apply only the definition which I have given to you. So here in previous question what happens? You have to identify the empty set. Here you have to identify, in this question you have to identify which is not a null set, which is not an empty set. So again you start writing all the sets in roster form. So your first part A, in A, when you write the given set in roster form, so how many odd natural numbers are there in the set of natural number that is divisible by 2? You can say no one. So it is an empty set. It has no element. This is empty set. Set of even prime numbers. It has one element, that is 2. Now in third part, that is the simultaneous condition. x is less than 5 and x is greater than 7. This is the simultaneous condition for x. X is a natural number. Same number is less than 5 and that the same number is greater than 7. It is not possible. If you take 4 as a natural number, it is less than 5. But it is not greater than 7. So that will not satisfy simultaneously. So it has also no element. It is a null set. Now last, x says that x is a point common to any two parallel lines. If you can take the example of railway lines, they never meet. There is no point common to two parallel lines. So that's why it has also no element. So in this way, your part A, C, D are satisfying the condition of null set, empty set. Part B is a singleton set, that is not the null set. So therefore, your answer of this question is the part B. Now next one. Which of the following is not an empty set? I am taking another example. Which of the following is not an empty set? A. Set of natural number less than 1. B. Natural number between 3 and 4. Between 3 and 4. C. The set of integers between -2 and -3. D. The set A equals to all x such that x square is equals to 2 for each x belongs to R. Again, you have to identify out of these four answers which is not an empty set. So in the same way you have to write all the answers in set roster form. So in first case, what happens? Set of natural number less than 1. Can you find a natural number that is less than? No. So it has no element. This is the example of empty set. Natural number between two consecutive natural number 3 and 4. 3 and 4 are consecutive natural numbers. It means there is no natural number between 3 and 4. So it is again null set. The set of integers between two consecutive integers, -2 and -3. This is also a null set. Now the set A is defined as all x. X is a real number and their square is 2. So it has two elements. One is -√2 and another is √2. So ABC are the example of empty set, and your D is not the example of empty set. So this will not an empty set. So that is your correct answer is D, because in this part you have some element in the set A. So this will not be an empty set. Now I am taking the question based on finite and infinite set. Which of the following is a finite set? Question number 6. Which of the following is a finite set? That is the question. A. Set of natural number. And set of rational number Q. C. Number of days in a week. In a week. D. Set of concentric circle. You have to identify out of that which one is a finite set. As you all aware with the facts that set n is an infinite set. There are infinite elements in the set of natural number. Similarly, in the set of rational number is also infinite. Now last part, set of concentric circle. By taking one point as a center and with different radius you draw a circle in the same plane. So your number of circles that you can draw is infinite. You start changing the length of the radius, you can get a different circle with the same center. So D is also infinite set. But when you reach to part C, number of days in a week, you can count the number of days in a week. There are 7 days in a week. So that is a finite set. So this C is the correct answer. By changing the conditions, you can find the answer whether the given example are finite set. Which of the following set is a finite set? Another question I am taking. Which of the following is a finite set? A. Set A is defined as all x such that x belongs to Z and x square minus 5x plus 6 equals to 0. B. Defined as all x such that x belongs to Z and x square is even. C. D equals to all x such that x belongs to Z and x is greater than minus 10. I want to tell you one tips about that. Sometimes what happens, all the answers are correct. D, all of these. All of these. So now you identify that. In this, you will get 2 elements, 2 and 3. Here, x belongs to that, x square is even. In the set B, you will get x square is even. There are infinite elements. Which of the following is infinite set? Set A. Here greater than minus 10. This is also infinite. This is infinite. We are talking about which of the following is a finite set. So this is infinite because they are infinite integers. Their square is even, like -2, -4, -6, 2, 4, 6, and so on. They are infinite. So it has infinite element. And here -9, -8, and so on. That is also infinite. So which one is right? All of these. Not. This is also not the correct answer. This question is very confusing. So there is only one example, that is A. This is a finite. This is example of finite set. So in all that exercises, you must notice that to identify finite and infinite set, or empty set, null set, or singleton set, or equal sets, first of all we have to write the given set in the roster form, and then we start making our observation about them, what is required for the question, and then we go according to it. So that is one thing. Now I am taking subset. A set A is said to be a subset of a set B if every element of A is an element of B. For example, set A has element 1, 2, 3, set B has element 1, 2, 3, 4. So here we can notice that the element of A, every element of A are present in set B. So A is subset of B, and we can write A is subset of B. If we take example set A as 2, 3 and set B has 1, 3, 5, 6 and so on. So in this case 2 is a member of A, 2 is member of A, but 2 does not belongs to B, therefore A is not a subset of B. And we can write A is not subset of B. This is the method by which we can denote whether the set is a subset of another set or not, whether it is a set, this set is a subset of another set. So in this way we can denote it by this symbol. Now I would like to mention some note on this definition. Note. Number 1, empty set is a subset of every set. Second point, the given set is a subset of itself. third point. Number of subsets containing number of subsets of a set containing n elements is equal to 2 to the power n. How it happens? Number of subsets by taking 0 element. Number of subsets by taking no elements, that is equals to NC0. Out of n, 0, no one is taken for that. So that is fine, because you know that null set, empty set is a subset of every set. That is 1. Now number of subsets by taking 1 element. So it is equal to NC1. And number of subsets by taking 2 element, 2, that is NC2, and so on. Number of subsets of taking all at a time is NCN. So your total equals to NC0 plus NC1 plus NC2 plus and so on plus NCN, that is equals to 2 to n. By using the formula or by using the property of binomial theorem, in the chapter binomial theorem you can see this property, sum of the binomial coefficients is 2 to the power n, that is the binomial coefficients. So number of subsets of a set containing n elements is equal to 2 to the power n. These are the 3 notes on subsets. Now I am coming to the another definition, superset. How can we define superset? Superset. If A is subset of B, if A is subset of B, then B is called superset. And we can write B now proper subset. Subset, there is difference between the subset and the proper subset. So I am writing the definition of proper subset. When I say a set A is a proper subset of B, proper subset. If A is subset of B and A is not equal to B, then A is a proper subset of B. For example, set A is ABC and set B is ABCD. So you can observe that all the elements of A are present in B, but there is one element in the set B, that is D, which is not a member of A. So in this case A is not equal to B, and this satisfies the definition of subset. Therefore A is a proper subset of B. What we do for proper subset, we use this symbol only. We are not making equal sign in this at this place. You remember this point. This is the difference between proper subset and the subset. Next one, universal set. How can you define the universal set? It is very difficult to define it. If all the subsets under the condition, if all the subset under the condition is a subset of larger set, then this larger set is an universal set. So, one question may be arising in your mind that universal set is same for every set? Not. Universal set may varies from situation to situation. I am giving some example. I want to make it clear. Set A has element 1, set B has element 1, 2, set C has element 1, 2, 3, and universal set U has element 1, 2, 3 and so on to 10. So, when you have taken all the sets under consideration like this, set A, set B, set C, and here U is the largest set among all, so all the set A, B, U, C and U are subset of U, so U is the universal set for this situation. And you can make your universal set bigger than this also, which has more element as compared to this universal set U. So universal set may change, it can be taken, it can vary from situation to situation. Today I will stop here. I will start